All right, in this video, I'm going to go over an introduction to integration. So let's start out with the example f prime of x is equal to 5x to the fourth. Can you work backwards and find out what f of x is? Well, if we think about this hard enough, we can realize that if we had f of x equals x to the fifth power, we know that when we take the derivative of that, we're going to get 5x to the fourth. Okay? But is there more than one answer? Well, what about if we had x to the fifth plus 7? Well, f prime of x would still equal 5x to the fourth. And then we can continue this process with any constant. So if we had f of x equals x to the fifth minus 100, we're still going to get 5x to the fourth. So this concept is called the antiderivative. The antiderivative. So we're working backwards from the derivative and getting the family of functions. Okay, so this is a family of functions. So there's more than one answer with this. And what we'll do is we'll show you with the symbol and we'll show you some formulas in our next examples. So the definition of the antiderivative, we're going to let a function capital F is an antiderivative of little f on an interval I if capital F prime of x is equal to little f of x for all x and I. All right, so let's try this one. Let's say we had f of x is equal to 2x. Okay, so can we work backwards to get what capital F of x is? Well, you might recognize that capital F of x would have to equal, one possibility is x squared. But as we saw in the previous example, we can have x squared minus 3, x squared plus 7, x squared plus or minus any constant would work when we take the derivative. So what we do is we write a plus c in our answer to represent that constant. Okay? And capital F of x would be considered the antiderivative. So x squared plus c would be the antiderivative of 2x. In our last example, if f of x is equal to 2x and little f of x is a derivative of capital F of x, then we can say that dy dx equals 2x. This is called a differential equation because it is an equation with a derivative on one side. So for example, if we had dy dx equals the constant 5, then the antiderivative of that would be y is equal to 5x plus c. So if we had dy dx is equal to f of x, and we multiplied both sides by dx, and we got dy is equal to f of x dx, if we apply this symbol, and this symbol is called the integration symbol, to both sides, we would get y equals the integral of f of x dx. Well, the integral of little f of x dx is equal to the function that we want, which would be capital F of x plus some constant c. So in other words, this is an integral sign, this symbol, and the integral of little f of x dx is called an indefinite integral. So the indefinite integral is a family of functions, and that's why we have the plus c after. Okay, so let's look at some basic properties of integrals. So the first example, since we know the derivative of a constant is 0, that means that if we have the antiderivative of 0 dx, we would get a constant as our answer, as the indefinite integral. Also, we learned with derivatives that if we had something that's linear, so for example, if we had the derivative of kx, where k is a member of the reals, its derivative is the constant k, so that means that the indefinite integral working backwards, we would get kx plus c as our indefinite integral. And also, just like with derivatives that we can factor out a constant, same thing with indefinite integrals, that if we had the integral of k times f prime of x dx. We can factor out that k. It would equal k times f of x plus c. And just like we had our sum or difference rule for derivatives, we also have the sum or difference rule for indefinite integrals. So you can just take the indefinite integral individually of each and add or subtract and have 1 plus c at the end. All right, so let's try some of these properties. So the first example, let's say we had the integral of -5 dx, so that's going to mean with respect to x, so we're going to put the x variable on when we take the antiderivative. So this would equal -5x plus c. And in the next example, let's say we had a 5 multiplied by f prime x dx. Now we don't know what f prime is, so we're just going to use symbols for this one. So this would equal, and we can bring the 5 out front because 5 is just a constant. So we would get 5 f of x plus c. And then the last example, let's do one with addition. So if we had the antiderivative of 3x squared plus 5, we can split that up and do each part individually. So the antiderivative of 3x squared plus 5 would be x cubed for the 3x squared plus 5x for the 5, and then plus c. So on our examples earlier, we were using functions for the derivative as something that you can easily recognize working backwards. So for example, we had 2x. So we could recognize that the derivative of x squared is 2x, so the antiderivative of 2x was x squared. Well, that's not always going to be the case. So for example, if we had the antiderivative of x to the 7th dx, might not be as easy to recognize what the antiderivative is. So that's where we have what's called the general power rule for integrals. So in this case here, in general, the antiderivative of x to the n dx is equal to x to the n plus 1, so you just add 1 to the exponent, then divide it by that n plus 1, and then put your constant plus c on there. And this works for n not equal to -1. So in this case here, this would equal x to the 7th plus 1 divided by 7 plus 1, which is equal to x to the 8th over 8 plus c using the general power rule. Okay, and just like before with derivative, when we learned our power rule for derivative, this is what we're going to use from the start until we learn a few other techniques. All right, so we can do this one with a negative exponent also. So we're saying this is x to the -3 plus 1 divided by -3 plus 1. So this would be x to the -2 divided by -2 plus c, which could also be written as -1 over 2x squared plus c. Okay, slightly harder if we add a constant to it. So let's say we had 7x squared, so we're going to use our constant rule. So we can bring that 7 out front, and this becomes 7x squared, the integral of x squared dx. So this is going to equal 7 times, and then we're going to use the power rule on the x squared. So that would be x to the 3rd over 3 plus c. So our answer would be 7x cubed over 3 plus c. All right, for the last part of the video, let's look at some tricks that we can do to make things a little bit simpler. So remember, we have this power rule, so we want to have exponents. So there's going to be a lot of times where we're going to have to rewrite the original function that's in the integral. So for example, if we had the 5th root of x, well, we're going to rewrite that as x to the 1/5 dx so that we can see what the exponent is. So now we know if we add 1 to that, that would be x to the 6/5 divided by 6/5. So the answer would be, if we multiply by the reciprocal, 5, 6, x to the 6/5 plus c. Okay. Similar fashion, if we had the integral of 1 over x to the fifth, that is equal to the integral of x to the negative 5 dx. So again, we add 1 to it, so we would get x to the negative 4 over negative 4. So that would be negative 1 over 4x to the fourth plus C as our answer. All right, and then the last example, we have a 1 over 5x cubed. I would rewrite this as, I would bring the 1/5 out front as a constant and then call this x to the negative 3 dx. So again, if we add 1, we would get x to the negative 2 over negative 2. So we got x to the negative 2 over negative 2. And don't forget, we had the 1/5 that we had factored out. So this would be negative 1/10 over x squared plus c. Okay? So that was an introduction to integration. I hope you liked the video. If you did, please like and subscribe. Thanks for watching.